All right, so what we're going to get into next is the idea of basic design. We're going to cover a number of different design concepts in this course, but we're going to start off from the very, very beginning. The largest problem that most students have when they're starting a new problem is they don't know really where to begin, which line of code to write. Why am I going to write that line of code? So this process is going to help get you started on that every single time that you get going. So I want to remind you that all of our programs, all of our computers, basically only do four basic operations: input, processing, storage, and output. We know what those operations are. We know input reads data from the user. We know processing manipulates and modifies that data. We know storage is used to store the results of that modification. And finally, we know output is used to give feedback to what we just did, what we changed, or how we modified things. Okay. Now, we also know that processing and storage will typically be grouped together since they almost always happen directly one after the other. Once we finish manipulating something, we then need to store the results or we lose them. So what we do is we typically group those things together and reduce our acronym from IPSO just down to IPO. So it becomes input, processing and storage, and output. And nearly every program you create, of course, is going to follow these basic operations in that order exactly, and it's never really going to change. Now, the programs are going to grow in scale, so you might see them repeat themselves over and over again, especially when we get into the gaming content. You're going to see this repeat itself 60 times a second, as we've said in the past. But that's not the only consideration and the reason that we talk about these four operations at all. They also help us organize our programs. So when we face to a problem that we have to solve, we're going to break it down into a two-stage procedure. The first one being, let's brainstorm what is done for each one of these different portions of the program. That's a great way to really kind of break the problem down. What kind of input is occurring? What kind of processing and storage needs to take place next? And finally, what kind of feedback do we need to give to the user? So we're going to do this in the form of a graphical organizer we call an IPO chart, which is really just a table of 3 columns. So once we're done producing that table, we're going to then program each of the IPO portions in order from left to right. So we code the entire input column from top to bottom. Then we move on to the processing and storage column and code it from top to bottom. And finally do the exact same thing for the output column. Now, the next thing is we gotta kind of break this down a little bit. It's important to realize that when we do design, we're not really designing for any one specific language. Our designs are meant to be general in nature, so we can hand them off to a programmer and they can then implement that design in whatever language they work in, whether they're working in a web-based language like HTML, or whether they're working in a standard programming language like C# or Java or C++. And every language is different, but they all have the same kind of basic fundamental concepts that they can perform. They can all do output, they can all do input, they can all do processing, right? So how they go about it, that's up to the programmer. So for example, if I'm asking the user for information in a console program, well, that's a very specific process. Ask, read, ask, read, ask, read. But if I'm doing that on a web page, that's completely different. There's a whole bunch of text boxes that are filled out, and then the user just hits OK. And then all that data at once is read in by the program. So it's a very different operation. So it's up to the programmer to decide how to implement those things. All we're doing is kind of setting up the logic of what needs to be done next. Kind of like a to-do list, but a little bit more organized than just simply one item after the other. We're actually going to categorize these things as well. So since all these designs are what we call language independent, that means I should never ever see any form of code appear in the actual design document itself. We want to make sure that it's general in nature. All right, let's move on a little bit. So they're called IPO charts because the acronym is going to serve as the column headers for our chart. So what goes in each column? First up, let's talk about the input column. I've broken it down into 3 sections. The input column is all about variables. The processing and storage column is all about the actual program logic. And finally, the output column is all about feedback. But let's go into a little bit more detail on that. When I say input is about variables, what do I actually mean? Well, I actually mean all of the variables in the program, not just the ones we're going to get from the user. So that is going to be part of it. So think about what variables you need to retrieve data from the user. So those are your input variables. What variables do you need to do any form of calculation? Well, those are our calculation variables. And what data do you actually already know and what is not changing? So those are our constants. And we typically define them in order of constants, input variables, and then calculation variables. So the exact opposite of the order that you see listed here. So that's the first key. The processing and storage section, we'll come back to that in a second. Let's keep focused on the input column first. So as I said, it consists of the input variables, calculation variables, and constants. Great. So it's going to help us determine which variables we're going to require for our program. Not just which variables in terms of their names, but also their types. So for every single variable, what we want to do is we want to specify its data type as well as its identifier. It's almost like defining the variable, but we don't have to put the semicolons or anything like that. It's just the data type, and all the data types in most languages are pretty similar, so it's safe to assume, a double exists everywhere where you're going. So double class average. And then for constants, we're not going to use any special keywords like final or const or anything like that. We're just going to spell the name using screaming case, and that will be indicative enough to the reader of the design that it is indeed a constant and meant to be a constant. And of course, just like any constant, we have to specify what that value is when we state it. Now notice that I'm not using the word define because we're not defining anything. It's not code. It's just what is the data type, what is the name of it. And if we know it, we can also state what the value is. So that's what's going to go in here. Do your constants first, then your input variables, then your calculation variables. Okay? Now going on to that, once we know what variables we need, let's take it a little step further. What kind of processing is required for this whole process? Well, there we go. This column is all about the program logic. Now, again, no code, just simple instructions. Think about what needs to get done. So the most important things are the data requests and retrievals. You're going to do that first. This is where you're going to be prompting the user and retrieving that data. We're not actually going to write the prompts or anything like that, but we are going to state what we're doing and what data we're actually trying to get. Then we're going to do any calculations, maybe some comparisons if necessary, and any other actions that are required. Maybe you need to round some data or something along those lines. But we don't need to spell everything out here. We're really talking about the major concepts. We're talking about the overall design structure itself. So the logic should be in order because when you go to program this later, you want to make sure that you're programming from top to bottom. So that's why we want to do data retrieval. So they ask and read the first thing in the first thing in this column. How are we going to state it? For every single item that you put in here, just use a bullet point. One bullet point per piece of processing. And that's it. And how though? What we're going to do is so we know what kind of processing is occurring, we're going to use special keywords. So I've got a bunch here to kind of get you going. Ask, read, that is for any form of prompt and retrieving of data. So I might say something like ask/read username. That doesn't tell me what the prompt is, and I don't need to know because that's going to be up to the programmer. Read does say that I am reading it in, and then when I say ask read username, that tells me that I'm going to be storing it in the variable username. Now, of course, that variable would have had to been stated in the input column first. Set is for when you're just assigning a value. You're not calculating anything, you're just setting a variable to a value. So it might be something like set, set username to Steve, right? So set username equals Steve. Calculate is when you're actually doing some form of calculation. It could be concatenation. It could be an actual full mathematical expression. So it might be something like calc rectangle area as length times width. So you can do equations. So we have that keyword first, and that's what kind of gets the whole process going. A couple more keywords that are very consistent in our designs are things like increment and decrement. So it might be something like increment score. Decrement, count or something like that. So it could be very simple. Now, obviously, these keywords are not going to cover every scenario. So what do we do if we come into an action that we need to do that's not specified? So that's why it says any other actions. Well, the truth is we make it up. Make up a keyword that makes sense. So for example, if you want to round some value down, you might create a keyword and just call it round down. And then you might say the variable that you're rounding down. So it might be something like round down num students or something like that, or round down average mark. Whatever it is that you want to do. And if you want to specify maybe a little bit more data, you might want to specify, for example, the number of decimal places. It might be something like round average to 2 decimals. So we've specified what's going on. So that's all we're going to do here. And then finally, we get into the final column. This is the most straightforward column. This is all about the feedback, the output. I don't want you writing prompts in here or anything like that. This is just for that final text feedback. And what we want is the text and the information that's going to be displayed. Again, it comes back to the programmer to decide the format to do that in. You don't need to specify that here. You don't need to specify any colors or anything like that. That's all up to the programmer. We're just talking about design here. So on here, we're looking at, so this column consists of the exact text. So we're going to use plus signs to kind of group and concatenate text and variables just like we normally would. But again, it's not for input prompts or anything like that. It's just the actual text. We're going to use quotation marks so we can specify what is text and what is a variable. And then we're going to use one keyword in this entire column, display. And that is clear to the reader, the programmer, what they're doing right now. They're displaying. Well, if it's Java, it might be system.out.println. If it is C#, it might be console.writeline. If it is a game, it might be drawing an image on the screen. Who knows? So here's a simple example. Display, quote, the area of the circle is, quote, plus circle area. So that tells me everything. It tells me what I'm doing, tells me the text, the exact text, and the variable that I'm concatenating to it. That's all I need to do. So now what we're going to do is we're going to do a quick example to try and bring this all together so you can see actual design in motion here. So let me kind of, I'm going to do this on a Word file so I can actually write. And we'll do this together here. Let me just kind of minimize this here. Where's my Word file? There we go. So here's my program. Create a program that will calculate the difference in calculate the difference in travel time from Earth to Mars between a rocket and a light speed laser. To do this, you will ask the user for the speed of the rocket in kilometers per second. You know that the speed of light is 300,000 kilometers per second, and Mars is about 63 million kilometers away. Report your findings. So input is all about variables. So we want to do our constants first, then our input variables, then our calculations. So our constants are things that we know. Looking at this question, there's only a few things that we know. We know that the speed of light is 300,000 kilometers per second. So I can do that. So I want to specify that I'm storing that. So that would probably be a double. And because it's going to be a constant, I want to make sure that I'm using the lowercase d. Double, because I'm using a constant, I want to use screaming case. So I'll call it light speed. And I'm going to set it to 300,000. Okay, I don't put the units or anything like that because we never do units when we're storing data. Okay, next up, what other known data do I have? What other constants? Well, Mars is 63 million kilometers away. Okay, so that's also a double. And we'll say Mars distance, Mars dist equals 63 million. 63, 1, 2, 3, 1, 2, 3, 63 million. So that's all of my constants. I don't really have any other known information. All right. What am I trying to calculate? Well, I got to calculate a few things here. So it says create a program that will calculate the difference in travel time from Earth to Mars between a rocket and a light speed laser. To do this, you're going to ask the user for the speed of the rocket. Now, I want to think about my input variables before I think of my calculation variables. It says the only thing I'm asking the user for here is the speed of the rocket. All right, so let's create a variable for that. I'm going to say double rocket speed. Now, I'm going to create a bit of a gap here because this data is not related. So it's kind of like what we do in our code, but just for readability purposes here on the table as well. Do I need any more input? No, I don't. That's the only input that's happening here. So now my goal is to figure out, well, what am I calculating? I'm calculating the difference in travel time from Earth to Mars between a rocket and a light speed laser. So that tells me that I need to calculate the travel time of a rocket to Mars, the travel time of a light speed laser to Mars, and the difference between those two. Okay, so the double rocket time, and we want double, let's say laser time, or let's say light time, and finally double time diff, short for time difference. Now, thinking about this, is there any other variables that we need to get for input or calculate or anything like that? No, that seems pretty much everything. Okay, so now we go into the processing section. The first thing in every processing section should be retrieving of data. So no matter what, I know the first thing I'm going to be writing in here is ask read. Well, what am I asking and reading for? Only the rocket speed. That's it. That's all I need for my my prompting. I don't have to specify the prompt or anything like that. Just ask read rocket speed. Programmer will do the rest. Next step of the puzzle. I need to do my calculations. I need to start calculating things like the time it takes, the travel time for the rocket to get to Mars. Okay. Well, I know that the rocket travels at this speed and it needs to get this distance. So that's a fairly straightforward calculation. So I'm going to use the keyword calculate. Calculate. What am I calculating? I'm calculating rocket time. And it's equal to Mars distance divided by rocket speed. Now we're going to modify the size of these columns a little bit to make it work with us a little bit here. There we go. So our rocket time is the total distance divided by how fast we're going, right? And now we need to do the same thing for light time. But before I do that, I'm going to create a gap here because asking and reading has nothing to do with these calculations. Now we want to calculate the light time, which is basically the same idea, the Mars distance divided by the speed of my light, which is our light speed. Oops. There we go. And then finally, the last thing we need to calculate is just the difference in the times, which is just subtraction. So calculate time diff. Now, which one should I subtract from which? Well, I know that the rocket is going to take way more time than the light speed laser. So that's going to be the bigger number. So in order to get a nice answer, I'm going to subtract the light time from the rocket time. So I get a nice positive number. So this is going to be rocket time minus light time. Now, I'm sure some of you right now are saying, but what if you have a rocket that moves faster than the speed of light? We don't yet, so let's not count it. So now I've broken that up so it's nice and clean here as well. We don't have to do anything special. And the last piece of the puzzle is simply to display the results. Now, the question is only asking us to display, calculate the time difference, but from the user's perspective, they want to be able to verify that. So in this case, it's probably a good idea to display all three calculated values: how much time the rocket took, how much time the light took, and what the difference was between the two. So we're going to use the display keyword. Display, let's say something like rocket time, and we'll say it's in seconds because it's measured in seconds. Is it seconds? Yes, it is, because it's kilometers per second. Yes. So that's in seconds, and then we'll concatenate that with, that's a weird quotation mark. So let's fix that if we can. There we go. We'll concatenate that with rocket time. And now we'll do the same thing for our light time. Let's say light time in seconds again, and weird quote, and we'll concatenate our light time. And finally, not least, we got to calculate the difference, right? Or sorry, we have to display the difference. Display, oops, there we go. Let's say the rocket took, weird quote, plus time difference more seconds. And that's it. So let me just split these up because those aren't related. There we go. So the rocket took however much the time difference is, more seconds, because everything is measured relative to seconds. And that's all I would expect from you for an IPO chart. Now, the beauty of this is we did a pretty solid job of this. If you look at this, and this is a really good design. Remember the old proverb, measure twice, cut once. Put all your effort into the design and it'll make the programming really easy. How hard is it going to be to go create these 6 variables and then do your prompt and then do your quick calculations, which we now know the formula for, and then do your final feedback? This is going to take you about 3 minutes to actually code now that the design is done. We already put the thought into the planning and we're good to go from this point. And that's it, ladies and gentlemen. That's how we handle our IPO designs. Good luck and have fun.